So we're going to talk about SSA and HL. And we'll talk about what those are in just a second. So notice on your, if you look at your graphic organizer, you notice there's not a bubble for SSA. There's not a bubble for side-side angle. And the reason that is, and we should write this maybe in a margin or something, that SSA, side-side angle, doesn't work to show that triangles are congruent. So we don't have an SSA theorem, we don't have an SSA postulate. We can't use SSA to show that triangles are congruent. One way to remember that is if you spell it backwards, you get something you shouldn't say in geometry class. So I want to show you why SSA doesn't work. So I'm going to draw a triangle. Like so. And we're going to say that this side is 8 and this side is 5, and we know this angle. So we have a side-side angle triangle. I don't know what this side would be, say 58 degrees. So now I'm going to draw another triangle that has side length 5, side length 8, and a 58-degree angle that is not congruent to this one. In order to do that, what I'm going to do is pivot this side on this vertex. And it's going to swing around in a half circle. And it's going to hit the triangle back over here. And that side length is 5, this side length is 8, and that's a 58-degree angle. And this small triangle is not congruent to the big triangle. So that's why side-side angle doesn't work, because we can end up with more than one triangle that has the same two sides and the same two angles. All right, folks, let's put the technology away, please. So we cannot use side, side, side to show that triangles are congruent, except in one case. And that case is when we have a 90-degree angle. So if we have a 90-degree angle, and this is 8, and this is 5, and that's 58 degrees, this side can't swing around and touch anywhere else. That's the only place that it can touch. So if I have a right triangle, I can use side-side angle to show that two triangles are congruent. But instead of side, 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 we call it hypotenuse leg. We have the hypotenuse of the triangle and the leg of the triangle. So that's what HL stands for. So that's going to be what goes in our last box, or our last bubble in our graphic organizer. So the HL theorem is hypotenuse leg. And what it tells us is, in words, if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So if we have two right triangles and we can match up the hypotenuse and a leg on one right triangle, then that guarantees us that the triangles are congruent. Now let's think for a second about why that would work. If we know that this is a 90-degree angle, and for example this is a 58-degree angle, can't we figure out the third angle? How would we figure out that third angle? Add these two together, subtract from 180. So then I could figure out this angle. Well, now I don't have a side-side angle triangle, I have a side-angle-side triangle. So if I have a right triangle, I can turn it into a side-angle-side triangle. So that's why hypotenuse leg works. Where here, I can't necessarily figure out that third angle because there's two possibilities for that third angle. Here there's only one possibility. So on your graphic organizer, you have two little triangles drawn there. So let's mark those for what we're talking about here. So on your graphic organizer, your triangles look like this, and this is my 90-degree angle. So the hypotenuse, which side of a right triangle is the hypotenuse? The way I drew it here, it's the slanted side, but we could draw it a different way. So how do we know which one, Matt? The hypotenuse is the longest side. Or what's the other way we can think about where the hypotenuse is? What do you? Well, if I draw it this way, it's slanted. I could draw the triangle so all the sides were slanted. What's opposite the right angle? So the hypotenuse is opposite the right angle. So it's across the triangle from the right angle. So we have the hypotenuse of the triangles congruent and a leg of the triangles congruent. So that's how we could mark our picture. Hypotenuse is the longest side, or the side across from the right angle, and the leg is one of the other sides. So all I want to do today is look at a couple of examples using hypotenuse leg, and that's really all we're talking about today. So everybody good here? Everybody have that filled in on their graphic organizer? Okay, so let's look at an example. I'm going to draw a picture here. And let's see what I want to do. This, like so. And I'm going to say, are these triangles congruent? And we're going to, and then if so, why? So think about that for a minute. All right, so we want to know if these two triangles are congruent. Well, what we want to do is look at the two pieces. So we have a couple of things marked. We have this marked. So what do we know about these two angles? They're congruent, and what kind of angles are they? Right angles, 90 degrees. So what kind of triangles are these? Right triangles. And what side do we have marked here on the right triangles? We have the hypotenuse. So if we could figure out that one of the legs of the triangles are congruent, then we could say that they're congruent by hypotenuse leg. Can we figure out a congruent leg? The side that they share is congruent to itself. So I'm going to do that in red because that's what we figured out on our own. That didn't tell us that. So those two are congruent. So we can say yes, they're congruent by hypotenuse leg. Have the hypotenuse and the leg of these two right triangles. All right, questions on that example? Okay, let's look at another one. I want to do a proof using hypotenuse leg. So here is my picture. And we have a 90-degree angle here, right angle here, right angle there. And we'll call this A, B, C, D. And we're given that AD is congruent to CB, and angle B and angle D are right angles. And we want to prove that triangle ABC is congruent to triangle CDA. So whenever we have, so first let's mark what we know is congruent. It says AD is congruent to CB. And we know that angle B and angle D are right angles. Whenever we have right angles, we should think, can we use hypotenuse leg? Can we save ourselves a little bit of work and use hypotenuse leg? So our plan is to use hypotenuse leg. And this problem is almost exactly the same as the one we just did. So we should have an easy time with the proof. So let's write down our givens. We know that segment AD is congruent to segment CB, and angle B and angle D are right angles. Those are given. So the first thing that I'm going to say, really we only need to come up with one thing here. What's the one piece that we're missing to show that these triangles are congruent? These are right triangles. Which part of these right triangles do we have we shown, are we given congruent? The leg. So what do we need to figure out that's congruent? A hypotenuse. Can we figure out the hypotenuse of these right triangles are congruent? We can say AC, segment AC is congruent to segment AC. And what's our reason that those are congruent? What is it? Reflexive. And I've noticed in the homework and in our examples, the book really likes the reflexive property. A lot of the proofs in the book use the reflexive property. So that's, a lot of them let us use the reflexive property, which is nice. So we know that I'll mark that those are congruent. So now I can say right away that triangle ABC is congruent to triangle CDA. And what is our reason there? Hypotenuse leg. So that was a really, really easy proof. So when you have 90-degree angles in your triangles, you think of hypotenuse leg. That can be an easy shortcut to help you out showing if those triangles are congruent. All right, questions on that example? So for right triangles, hypotenuse leg can be a nice shortcut. All right, let me pass your folders back. That's all we're talking about.